now time to continue with our review for the Unit 3 Geology exam. And now we want to talk about lesson number 10, Deep Time, How Old is Old. So in our previous review, we talked about what fossils were. So now we're going to use fossils in order to be able to date how old rock layers are. So this is going to be out of chapter 10 of your textbook. First thing you need to know is the difference between catastrophism and uniformitarianism. So those are two words that you've got to know for the exam. Catastrophism says that geological structures formed as a result of catastrophes, sudden events, such as the impact of an asteroid or a catastrophic flood, for example. Now, it does happen in geological history that catastrophes have happened, but it's not the only way of making a geological structure. So uniformitarianism is a different way of looking about how geological structures form. So the idea is that the physical processes that occur today, such as, let's say, sedimentation. So in the ocean, calcium carbonate makes limestone, and to make a layer of limestone like 1 millimeter thick, it takes like 1 million years. So that's how long it takes today for that to happen. So we assume that in the geological past, it also took 1 million years to make 1 millimeter of limestone. So that geology as it operates today operated likewise in the past at roughly the same rates, and that these processes are responsible for forming the geological structures that we see today. So notice that in order for uniformitarianism to work, we need to have a very, very old Earth in order for that to happen. And you should know that the person who came up with this theory was James Hutton. So know that name for the exam. Okay, next, got to know what a contact is. So a contact is going to be a boundary between two rocks. And so one kind of contact is going to be an intrusion. So that, like, for example, here's a particular rock layer, and then let's say that here's a magma chamber that intruded into it, and then it hardened into igneous rocks. So the boundary between the igneous rocks and, let's say these are sedimentary, is going to be an intrusion. And so that's a contact, it's a boundary. Okay, then you have sedimentary boundaries. So normally you have different layers of sedimentary rocks. So the boundary between this sedimentary rock and this sedimentary rock, that is a contact. Then you could have faults. So that if, let's say, a fault line runs through all of these rocks, then that's separating the rocks on this side of the fault from the rocks on this side of the fault. So a fault can be a contact. Then you can have unconformities. A unconformity represents a gap in the geological record. So in the case of a parallel, let's say that here's the original layers of rock, and then erosion takes place. So wind and rain and snow erode all of this material down until you're down to, here's the surface of the earth, and then new layers of rock are laid on top of it. So this thing here would be a disconformity. It's the boundary between these rocks and these. And so there could be hundreds of millions of years of rocks that are missing there. An angular unconformity is going to be where you've got tilted strata. So that you had rocks that were originally horizontal, and then they get tilted. So rocks that were originally horizontal get tilted so they're like this, and then new rocks get laid down on top of them. So this is a unconformity because maybe these layers of rock right here, maybe they used to go like that. But erosion took care of all of these rocks here. And so now you've got, there's the surface of the earth, and then new rocks were laid on top of it. A nonconformity is going to be where you originally had igneous rocks. So let's say that this area down here was molten, and then it turned into igneous, or this is the way that you indicate metamorphic rocks. But now erosion occurs, so now here's the level of the ground. So above it, you used to have igneous or metamorphic rocks, but it's been eroded down. And now on top of this, you now have sedimentary rocks. So this is, again, a unconformity. So what should you be able to do for the exam? Okay, if you're given a picture like this, you should be able to label which part of the picture represents a disconformity, which part represents an angular unconformity, and then which part represents a nonconformity unconformity. So how can rock layers be dated relatively? So there's relative dating, and then there's numerical dating. Relative dating tells you this rock is older than this rock. It doesn't say by how much. It doesn't say this rock is 100 million years older than that rock. It just says it's older. So here's how we can do things relatively. So first, you have the principle of original horizontality. So that rocks tend to be laid down horizontal. So that if you find rocks that have been tilted, like these, you now know that these rocks are going to be older than the rocks that were originally horizontal. Okay, next one is going to be superposition. So in general, the farther down you go in the rock layer, the older the rocks get. The higher up you go, the younger the rocks get. Now, you have to be careful, though, because sometimes the rocks can be flipped over and due to geological forces. But in general, the deeper you go, the older the rocks get. Lateral continuity means that if you've got rocks over here and you got rocks over here, then they are going to be the same age. So if they're on the same horizontal level, they're going to be the same age. So that's lateral continuity. Okay, then you've got cross-cutting relationships, so which says that, let's say, here's a fault that has cut across these rock layers. So the thing that is being crossed is older. The fault is younger, and the rocks that have been cut by the fault line are going to be older. Then you got baked contacts. So here's the sedimentary rocks. Here's an igneous intrusion, and what it did was it metamorphosized these rocks that surrounded it. So we can say that these metamorphic rocks are going to be older than what the this thing is going to be. Then inclusions means that if you find a rock, so here's your rock right here, and let's say that it's got little pieces of other rocks inside of it. So those would be called inclusions. They are inside of this rock. And so the inclusions had to have existed before this rock did, so that these things could be inside of this rock. So here's what you should be able to do on the exam. If you are given a picture like that, then you should be able to unravel it and figure out which event occurred first, which event occurred second, and so forth by using these principles. And then, how can we relate rocks from this location with rocks that are in this location over here? And one method is bilateral continuity, so that if we find rocks that are located over here and they are at the same horizontal location as the rocks over here, then we can assume that the two rock layers at one time were connected to each other, and then erosion has separated them. And so that's one way of saying that these rocks over here should be the same age as these rocks over here if they're at the same horizontal level. Another method is similar rock types. So in this picture here, on the left-hand side, you're seeing some limestone, and then underneath it is a different kind of rock, and then underneath it is another kind of limestone, the gray one, the dark gray. And then at a different location over here, we find those same sequence of rocks. So we find the limestone, some other kind of rock, and then underneath it is the darker limestone. So if we know the age of the light limestone over here, then we can assume it's the same as the age of this light limestone over here. Now you notice that the thickness, though, can change. And the reason why the thickness can change is it might have formed under different conditions. So maybe for that very thick white layer there, maybe that formed at a delta where a lot of material was coming out of a river, whereas that thinner layer, maybe it formed out to sea. So it formed at the same time, but it formed in a different location, and that's the reason why it has different thicknesses. Okay, we could also use fossils. So one thing that we found from the last review lesson was fossils can change. As an organism evolves, it might get bigger, it might get smaller, it might have different numbers of attachments to it, but it evolves, it changes. So that we can use fossils in order to date rock layers. So if we've got a rock layer over here and it has a certain set of fossils in it, and over here we find that same set of identical fossils, then we can assume that those two rock layers are of the same age. All right, let's take a break. When we come back, we're going to talk about how rocks can be dated using radioactivity.